In this video, we're going to go through the revenue, cost, and break-even problem from the Section 4.1 activity. So in this problem, we have a plant that makes riding lawnmowers. They have fixed costs and variable costs, and these are things that we have discussed before. So our cost equation here is y equals 48,000 plus 1,400x. Our 48,000 is going to be our fixed cost, and our 1,400 is going to be our variable costs. Our revenue equation is 1,800x because the mowers are sold for $1,800 each. X is the total number of mowers produced and sold each day, and our costs are in dollars. So the first question asks us to graph both equations using the graphing calculator on Desmos and paste the link or image of your graph below. So I have my graph here. I've already typed my equations on the left-hand side. You can see the settings that I used for the window are x from 0 to 200 and y is from 0 to 300,000, and that allows me to see the point where the lines are crossing. So I can put the link or the image into my notes. One nice thing about using the link is that when you use the link you can click on the graph later, and so sometimes that might be helpful in terms of if you want to go back to the graph and see what your equations were or see what the points on the graph are. You might find that helpful. The picture is nice because you can see the picture directly, so you could also paste both the link and the picture into your notes if you would like. Question 2 says how many units must be manufactured and sold each day for the company to break even. So remember, we're looking at cost and revenue. That's what these equations are. And so when the company breaks even is when the costs and revenue are equal, or in other words, it's where the cost and revenue lines cross. So if I click on the point, I can see what the coordinates of that point are. The book will maybe show you a different way to do this. You can also set these equations equal to each other and algebraically solve for x. If you want to do that too, that's fine. However you think is the best way to do it. So I have my point here. I'll bring that back up. And the question is how many units must be manufactured each day for the company to break even. So remembering that my equation here, x is the total number of mowers produced and sold each day, and then the y is the amount in dollars for the cost or the revenue. So I'm looking for the x coordinate for how many mowers or units must be manufactured each day to break even. My x coordinate there is 120. So my answer for question 2 is 120 units. And I'll write a note to myself that it's the x coordinate of the intersection point. Question 3 says fill in the blank with the word loss or profit. The region between the lines to the left of the break-even point represents the blank when X riding mowers are manufactured. So looking at my graph, to the left of the intersection point is this area over here. And so I can see that in this area, the red graph is above the blue graph. And remember, the red graph is the cost with the colors that I have set up right now. The red graph here is the cost and the blue graph is the revenue. So in this area, costs are greater than revenues. Costs are greater than revenues, that means that it is a loss. So the company is losing money because your costs are more than the money that you have coming in. So the word loss would go in that blank. And then in question 4, fill in the blank with the words loss or profit for the region between the lines to the right of the break-even point. So go back to my graph, look to the right of the break-even point, that's this side. Revenues here are greater than costs because the blue line is above the red line. So for any number of mowers, any x coordinate, my revenue is going to be greater than my cost. So that means that it is profit because I am making money, and that is a good thing. So I would fill in the blank with the word profit.